The topic is solving initial value problems by separation of variables. Alright, let's do this example. Find an explicit solution of the initial value problem dy dx is equal y squared minus 1 over x squared minus 1, y of 2 equal 2. Again, same thing like previous examples. The goal is to have dy's and y's on the left side and the dx and x's on the right side, and we can move things diagonally as much as we like. So y squared minus 1, I'm gonna move it that way, so therefore I'm gonna have dy over y squared minus 1, but the dx, I'm gonna move it that way, and then I'll have equal dx over x squared minus 1. Now I have the y's and the dy on the left side, the x's and the dx on the right side, so I can integrate both sides. And now of course you need to notice that you need to use the partial fractions on both sides. So how do we do that? We can do it for 1 because they look the same. So let's do it for 1 over y squared minus 1. Now how do we use that? This is the same thing as a over, if you factor y squared minus 1, you're going to get y minus 1 times y plus 1. So this is y minus 1 plus b y plus 1. Now to add the fractions, the common denominator will be y minus 1 times y plus 1. So this is the same thing as a times y plus 1, right? We need to multiply a by y plus 1, and we need to multiply b by y minus 1. Just did 2 steps in 1, and this will be y minus 1, y plus 1. The common denominator is y minus 1 times y plus 1. Now I'm going to distribute the numerator, so this will be ay plus a plus by minus b. That's a y minus 1, y plus 1. Now I know that this has to be equal 1, and I'm going to factor it. Factor y, you get a plus b, factor y plus a minus b equal 1. But what is 1? 1 is the same thing as 0y plus 1. Now I know that a plus b is equal 0. The coefficient of y has to be the same, and the constant has to be the same. So a minus b has to be equal to 1. How do I find a and b? Just add the left side. If I add the left side, I get 2a plus 0 equals 0 plus 1 is 1. So therefore a is equal 1/2. Now that I know a is equal 1/2, from here I can say b is equal negative a. Therefore b is equal negative 1/2. So I found b equal negative 1/2. So I can plug 1/2 here and negative 1/2 into b. So now I'm going back here, and I'm gonna do 2 steps at once. 1 over y squared minus 1 is the same thing as a over y minus 1. So 1/2 over y minus 1 plus b. B is negative 1/2, so negative 1/2 over y plus 1 dy is equal, since the right integral look exactly like the left integral, except instead of y we have x, so we get the same thing. So integral of 1/2 x minus 1 minus 1/2 x plus 1 dx. Alright, now this is simple. This is just, if we take 1/2 outside, integral of 1 over y minus 1 is ln of y minus 1. 1/2. Integral of 1 over y plus 1 is ln of absolute value of y plus 1. Same thing here. 1/2 ln of x minus 1 minus 1/2 ln of x plus 1 plus some constant. We might need to call it C1. We'll see yes, probably. Let's call it C1. Now, what's next? Now I can multiply the whole thing by 2. If I multiply everything by 2 on the right side and everything by 2 here, I can get rid of all the fractions. So I get what? ln of y minus 1 minus ln of y plus 1 is equal ln of x minus 1 minus ln of x plus 1 plus 2c1. So I'm going to call 2c1 c, and I'm going to say here c is 2c1. Alright, now what's next? Now I have to use the log properties. Let me do it here. If we use the log properties, this tells us the ln of y minus 1 over y plus 1. And of course I'm using also absolute value property. I'm using in the same time absolute value of a over absolute value of b is equal absolute value of a over b. I'm using that also. So same thing here is equal ln x minus 1 over x plus 1 absolute value, right, plus c. Now remember we're looking for y, so what I'm going to do, I'm going to take e of the left side is equal e of the right side, right, e of all that. Now if I do that, then I can use this property. Ln e ln of z, some number, is going to be equal z. So on the left side I'm going to get y minus 1 absolute value over y plus 1 is equal absolute value of x minus 1. Well, I'm doing product. Well, let me show you how I got that. So it's e to ln of x minus 1 over x plus 1 times e to the c. I'm going to do it in 2 mini steps. Now y minus 1 over y plus 1, e ln that will be equal x minus 1, this is plus 1, over x plus 1 times e to the c. I'm just going to write it on the left side, right? Now two absolute values are equal. Now remember, absolute value of a z equals some number k. I'm assuming k is positive, means z is equal minus or plus k. So in this case you get y minus 1 over y plus 1 is going to be equal minus or plus ec x minus 1 over x plus 1. I mean, let's use parentheses for all of them. Now what I'm going to do, I'm going to call minus or plus ec some constant c. So y minus 1 over y plus 1 is equal to some constant c times x minus 1 over x plus 1. So I'm calling c to be e minus or plus e to the c. Alright, what else? So now we need to find the c. So according to the initial condition, y of 2 is equal to, which means when x is equal to, y is equal to. So let's plug them in. Let's plug 2 for y and 2 for x. If we do that, we get 2 minus 1 over 2 plus 1 is equal to c. We plug in it into this equation. And remember, we're looking for y. Now we're looking for the c. So c, so this will be 2 minus 1, 2 plus 1, right? So this is going to give us 1 over 3 is equal to c times 1 over 3. Which means c is equal 1. Now we're going to go back and plug it in here. So the answer the implicit solution will be y minus 1 over y plus 1 is equal c, which is 1. I'm not going to write the 1. 1 times x minus 1 over x plus 1. I mean, you don't have to write the 1, right? And then I can go further, see if it looks better. I'm going to multiply diagonally. So y minus 1 times x plus 1 has to be equal, and then go that way. Y plus 1 times x minus 1. So all I have to do is FOIL. If you FOIL this, you get yx plus y minus x minus y. Same thing here. Yx minus y plus x minus 1. I move everything to the left side. Yx plus y minus x minus y minus yx plus y minus x plus 1 is 0. This will go with that. What else? This will go with that. They will cancel. Y plus y is 2y. So 2y minus x is minus 2x is 0. Divide by 2, you get y minus x is 0, which means the solution is y equal x. Right? Now, I want to show you something here. It's really important. So sometimes the easiest way to find the constant is go all the way till you get rid of the absolute value and then find the c. Now, what if you decide to find the c here, for example? Here. What's going to happen? Yeah, so let me write this equation on the back. So y minus 1, y plus 1 we said it's equal EC times x minus 1, x plus 1 with absolute value, right? You can even call it some C. Let's call this C. It doesn't matter, or leave it e to the c. Alright, so let's plug the initial condition here and see what we need to do. You can do it this way. You just have to be careful. So this is how you do it. We said when y, let me see, what is it? When x is equal 1, x equal 2, y equal 2, right? We know x equal 2, y equal 2. That's the initial condition. So let's plug it in. So we're going to get 2 for y, right? And then we're going to plug 2 for x. Now what are we going to get? We're going to get same thing on the left. This is what? 1/3. Absolute value of 1 over 3 is 1/3. And then absolute value of 1 over 3 is 1 over 3, which means e to the c is equal 1. Now let's plug it back here. So the solution will be absolute value y minus 1 over y plus 1. E to the c is 1, so 1 times x minus 1 over x plus 1, right? What does that mean? That means that y minus 1 over y plus 1 is equal minus or plus. So let's write them as 2 is equal minus x minus 1 over x plus 1, or y minus 1 over y plus 1 is equal plus x minus 1 over x plus 1. But we know the solution is going to be only one of them. So how are we going to know which one is which? Now we go back again to the initial condition, see which one will be satisfied. We plug for each one of them x equal to, so it's more work. X equal to, y equal to, and see which one we're going to pick. So let's use it here. If we use the first one, so it's going to be, let's plug 2 for y. Then now we're going to get what? 1 over 3 is equal negative 1 over 3. Doesn't make sense. So this cannot be a solution. This cannot be a solution. Now let's make sure this is a solution. Do the same thing here. Plug y, 2 for y, so you get 2 minus 1 over 2 plus 1 is equal to 2 minus 1 over 2 plus 1, which means 1 over 3 is equal to 1 over 3. This makes sense. So this is our implicit solution. And then we can finish it the same way we did earlier. Just multiply y minus 1 times x plus 1 is equal x minus 1 times y plus 1. And we just did it earlier, and then we get the same thing, y equal x. So you could, the initial condition, you have two options. It's usually better to get rid of the absolute value first, then find the constant. If not, you have to you're going to get two solutions, and then you need to get rid of one. Check each one of them. One of them would not work for the initial condition. And that's it for this problem.